Now I want to show an example of how types get converted when you do assignment between variables of different types. So this is an example we saw from a previous lecture. This is the adder.c example. It declares two variables, x and y, both integers, and asks you to enter two integers on the keyboard. It scans the two as decimal format and then puts their integer results into the variables x and y and then prints x plus y equals x plus y. So we want to make a few changes. First, let's try scanning them as floats. So we change x and y from int to float, and also you need to scan them in as floats, and the way to do that is to replace the %d with %f everywhere. Okay, so both in the scanf and in the printf parts. And then what I wanted to do is to say, well, let's try assignment. So let's declare integers a and b. And then what we do is we assign the values from x into a and y into b. You see, with these two lines. And normally, when you do assignments, they need to be of compatible types. So when you are, your source is a float, and your destination is an int, such as the case here with a gets x, b gets y, then you will have information loss. Why? Because x is a floating point. That means it may have digits after the decimal point. But when you assign that value to an integer, then the parts after the decimal point would be lost. And so that means a will get a value that may be different from x, even though it looks like a equals x on the screen, right? Same thing with b gets y, but in the end, b might not be equal to y. So to show this, then we add print statement. One line is we copy from the print above, but then we change this with additional note as int, and then %d here, %d, and then %d. So we change these back and then change x to a, y to b, and then instead of x plus y, we have a plus b. Okay, so this is just an additional statement to print the values back as integers after we copy their values. I should say assign, not copy. Copy means you keep the exact same data, but assignment means you are basically trying to write the value into a different variable, but that value may be different due to type conversion. And here we make one more change. Instead of two integers, we now say enter two numbers. Okay, so we can say two floating point numbers. Okay, so we can try to compile this program and see how it runs. So cc adder.c a.out. Please enter two floating point numbers. We can enter them as integers without decimal point, and it will scan them correctly as floating points. So we can try 15 and 30, is, see, it scans 15 as floating point 15, 30 as floating point 30, and result is 45 floating point. As integers, we get 15 plus 30 equals 45. In this case, they have the same values, or they are of equal value, mainly because we didn't have any decimal points after, right? We didn't have any digits after the decimal point. But let's try again. If we do 15.6 and 30.2, and it says, well, that's 15.6 plus 30.2 equals 45.8. But when we copy or we assign those values to integer variables, see, 15.6 now is shown as 15. The 0.6 part is dropped. And then 30.2 is now just 30. So instead of 45.8, we get 45. In fact, if we do it like this, if we do 15.8 and then 30.4, in one case, it will show 46.2. The integer case shows 45. So they can be off by more than 1 in the results. See, so what happens is when you do an assignment from floating point to integer, what's called truncation happens. Truncation or truncate means it drops, it cuts off everything after the decimal point. It does not do rounding. Rounding means if it's 4 or less after the decimal point, then you round it down. If it's 5 or higher, you round it up. So if it did rounding, then 15.8 would have been rounded to 16. 30.4 would have been rounded down to 30. And in that case, their results would still be a little closer, but this doesn't do rounding. Instead, it does truncation. And what happens if we have negative numbers? So if we do minus 15.8 and minus 30.4, then you see, it also does the truncation. So it's not always rounding down. Rounding down means it rounds towards a smaller number. But if it was rounding down, then minus 15.8, by rounding down, the closest integer to it rounding down would be minus 16. But look, it's minus 15 because it simply drops the parts after the decimal point. Similarly, with minus 30.4, it truncates and becomes minus 30. Okay, so this illustrates the point that you may lose information when you do assignment between different types. And so this is also the point I wanted to make by doing another float, and we can do F and G. Okay, and what do we do here? Well, we do F gets A gets X, G gets B gets Y, right? This is the use of assignment statement as expressions. So on this line, A gets X is evaluated, and then it has a value which can be used to assign to the variable F. And assignment statements are right associative in that you evaluate from the right towards the left. But during the conversion, you can probably predict what will happen, right? You can have information loss. So let's print this as second-handed float. Okay, so instead of x and y, we do f and g. F and g here. So let's give it another try. So let's do cc a dot out. If we do 30 and 15, they are all the same. If we do 30.6 and 15.2, you see the first float retains all the precision. The integers basically exclude or truncates the parts after the decimal points. But if we assign back to another pair of floating point variables, you see the f and g, so this is f, right? And then the 30.00, that's f, and then 15.000, that's g. So f does not get 30.6 because it gets whatever is after truncation. Because when you assign from the original float to the int, it already truncates it. And then when you assign it back to another floating point variable, it has lost that information. It has lost those digits after the decimal points in both cases. So that's why it looks like 30.0015.0 equals 45.000, okay? Rather than the full precision. Okay, so don't let these statements fool you. Okay, they might look like they are copying only if they are the same type, retain the same information. But these are assignment statements. So even though the equal sign is used, it doesn't make them necessarily equal due to the type conversion that happens. And C compiler will do the conversion for you, even though you might not say anything. C compiler knows the type of each variable. In fact, it knows the type of each expression as well. And it will do the promotion to the more general type when evaluating an expression. But when assigning, it will force the expression to be converted to the type that may be accepted by the variable. And that may result in information loss.